Hello everyone, and thank you for joining me. I am here to talk about the Metasploit Framework and the latest improvements to our payloads. My name is Spencer McIntyre. I go by Zero Steiner on all the various online services. I am the Metasploit Security Research Manager at Rapid7, where I work on Metasploit Framework full-time. I have been a Metasploit contributor since 2010. I got my start on the open source side of things, so I've been involved with the project for quite a while now. But today we are here to talk about the latest payload improvements to the Metasploit framework. But before we do, I kind of wanted to give a refresh on some of the different payload internals of what Metasploit considers to be a payload and the different types of payloads. Now, before we get into that, even one step higher, what are payloads? Now, of course, the Metasploit framework is divided up into quite a few different module types. Payloads, of course, are one of the more popular ones, but there's also exploit, auxiliary, post, encoder, NOPS. There's a lot of different module types, and payloads are the ones that we're going to be focusing on today. But even within the payload modules, we have different types of payloads. For quite a few years, there were three main types of payload modules. You would have stagers, stages, and singles. Now, when you would go ahead and use the Meterpreter reverse TCP payload, whether that was for Linux or Windows, you were using the Meterpreter stage, and that slash between Meterpreter and the reverse TCP part meant that the stager that you had selected was reverse TCP, so it would connect back to the Metasploit framework over a raw TCP connection, fetch the Meterpreter stage, and then go ahead and execute it in memory. If you had used the reverse HTTPS stager, it would do the same thing over HTTPS, and so on and so forth. Now, the stages that Metasploit has, there's not nearly as many of them as there are of stagers. We pretty much have shell and Meterpreter, and I believe there's also the VNC stage as well. Finally, we have the singles payloads, which the stageless payloads are a subclass of. So a single payload is non-staged. They're typically much larger because the stage is baked right into them. So in the case of Meterpreter, they can be very, very large. But the point is they don't use a stager to fetch the second piece of the executable code. Everything that's involved with the payload is sent up. So we have shell underscore bind TCP as in the example here. We have that for Linux and Windows. It's the same thing. That's a stageless single payload. Meterpreter underscore reverse TCP, same thing. We also have a number of single payloads, such as Windows exec that allows the user to execute a Windows command that is implemented through x86 or AMD64 shellcode that executes the command string as a payload. In addition to that, we have a whole bunch of single payloads for Linux that provide different shells using various executables such as netcat and bash, and those are all of our singles. Now, recently, Metasploit added a fourth type of payload, and this is, of course, the internal types that power all of our individual payload modules. And that fourth type is an adapter. Now, when Metasploit has the payload, each payload has a architecture. Typically, this would be the shellcode architecture. So if it's a 32-bit payload, it's typically going to be like x86 shellcode. 64-bit, it'll be AMD 64, but of course we also support MIPS shellcode along with a couple other different architectures. Metasploit also considers OS command to be an architecture. So if you have a command string that is executable code in the context of an OS command, if it's on a Linux system, it's going to be a bash command. If it's on a Windows system, it's going to be a cmd.exe command. PowerShell is also its own architecture for the Windows platform, just like Python is also its own architecture. Python and PowerShell are really good examples, though, because we don't have a lot of use cases where you can execute raw Python or PowerShell code directly as part of the exploit. But what we do see a lot of is the ability to execute an OS command. Over the past year, 2/3 of the exploits that Metasploit has actually added to the framework have resulted in OS command execution. That's either directly through command injection or through like serialization flaws or via some kind of means. In fact, in the example that we'll see shortly is going to be a exploit using the F5 big IP target. The vulnerability is the ability to smuggle AJP traffic, but once that vulnerability is exploited to create a new administrative user, we leverage existing APIs through the utilities and the diagnostic section of the application to be able to go ahead and execute an OS command, which is going to be our payload. So we see a lot of OS command payloads, and we don't anticipate that trend changing. Most likely coming into 2024 and 2025, most of the exploits that we see added to Metasploit will, at a low level, result in some kind of OS command execution. So, to accommodate that and to optimize for the most common case, we have added a new sort of family of payloads that these are implemented as adapters, and what they allow us to do is have an OS command that will fetch a executable file, download it onto the remote target, chomod it to make it executable, and then finally execute it. Now, Metasploit has had this capability for a number of years by using the command stagers. There was a few limitations with the command stagers, though, that made them suboptimal from both users and exploit developers' perspective, which we'll look at in depth and a little bit more in the demonstration section. But at a high level, the command stagers were less configurable and they were more opaque from a user's perspective. You couldn't necessarily change individual options on them, and you didn't necessarily know exactly what it was doing because the implementation would largely be dependent on what the exploit author intended for it to do. The exploit author would have to write that additional code, which brings us right into the second point of what kind of made it difficult for exploit authors is that it was additional code and logic that they would have to account for and be able to write in to their exploit, despite the fact that in almost all the cases, it wasn't actually related to the vulnerability. So it was just more work for the exploit developers as well. So with that, let's go ahead and take a look at a demonstration. So what we're going to do is use a recent exploit that came out for F5 big IP appliances that allows AJP requests to be smuggled and thus a new administrative account to be created. This exploit came out in early November, and it is unauthenticated RCE, so all we really need to do is set the rhost command. Now, what this is going to do is execute a OS command after that AJP request has been smuggled to create a new administrative user. And so we can see that we actually don't have any targets other than a command. Now, our default payload is going to be the Python interpreter, but this is one of the original adapted payloads, and thus the Python interpreter is wrapped to be executable as a Unix command by basically placing it within that Python-C wrapper. So when we go ahead and run this module, and it takes a couple of seconds because we have to create the user, which we can see has taken place. The administrative user is created. We are able to dump the admin hash, and then it's going to go ahead and obtain a login token before finally executing our payload, which can be that single OS command that's going to run the Python interpreter. So we can see that the stage has been sent and our session has been open. The module takes another couple of seconds because it needs to delete the user that we had created to clean up after itself. But here we have the interpreter session has been opened. So in this case, yeah, we can see that we have a Python interpreter session that was open. We just did a stage Python one-liner basically through this exploit module. Now, if we wanted to do something different, let's say we wanted to pull down a 64-bit interpreter via like curl or something like that. That's where the new fetch-based payloads that build on the original adapted payloads come into play. So let's go ahead and set our payload to a different one. We're going to do cmd linux HTTP, because the fetch-based payloads are organized based on the protocol that they're being used to fetch over. So we have HTTP, HTTPS, FTP, etc. So we're going to do HTTP, and we want to do a 64-bit staged interpreter over reverse TCP. Now, when we show our options, we have quite a few additional options. Now, this is really where one of the ways in which the fetch payloads really start to shine from a user's perspective. The users have much greater levels of control over the fetch payloads than the users would have had using the original command stagers that are largely being replaced by the fetch payloads. First of all, so we specify that we want to pull it over HTTP, but then we can specify which command we want to be able to go ahead and use. Now, curl is widely available on a lot of different systems, so that's the reason why we default to it. But if you wanted to use wget, you can simply swap out the command, and now wget will be used to pull down the payload. You can specify whether or not you want to delete the binary after it's being executed. You can control the name of the file that's going to be written to disk, the server information for Metasploit for where it's going to fetch from. This isn't required because Metasploit will figure it out for you under normal circumstances. But if you're like behind a NAT doing advanced port forwarding configurations or something along those lines, you can go ahead and specify the fetch server host to whatever value you need, and then the writable directory of where you want to store the payload. This is probably the single most important option that was never really exposed to the command stagers. This is particularly useful when you know that antivirus might have a directory it's configured to not check for, like an allow listed directory. And you know that the target process has write privileges to it, you can go ahead and specify that here, and then you can have the executable will be written to that location, chomodded, and then executed, and it'll carry on from there. So let's go ahead and run the module once again with this configuration. So it's going to look pretty much the same, but we'll see a slightly different interpreter after everything is said and done. So it's going to go ahead and this time run a curl command to fetch our interpreter file, which is going to be a elf executable. And then that elf executable is going to be chomodded and executed from that temp directory based on the configuration that we had. You just need to wait a couple more seconds for the module to clean up after itself. And here we have our interpreter session. So we are still running as root. We are in this directory, even though the executable was written to temp, and this time we are running the 64-bit version of Interpreter. So we can go ahead and see that we had the different payload that was executed. So that's a pretty good example of how these modules would be used from an exploit. Now, let's go ahead and talk about how these payloads can be used individually. Going back to that original Python one, we can use the individual payload and see that we have our options are all configured. Now, if we wanted to generate an OS command, not a command that would be pasted into like the Python interpreter, we would go ahead and use this new payload, and if we could generate it in the raw format, because it's an OS command, we want to keep it as raw instead of in hex, which would be the default from Metasploit's old days in dealing with shellcode. If we dump this out as raw, then we have an OS command that we go ahead and we can copy and paste this into bash or use it in our POC exploit, something along those lines. Now let's take a look at what that curl command would have been using the second payload that we used in our previous example. So here we have all of our options are all broken out. So we go ahead and set each of those individually. And then once again, once we had all of the required options had been set, we can go ahead and generate it. We're gonna give it that raw flag again. And we have our curl one-liner. Now, if we wanted to change this out, we can go ahead and set fetch command to wget, run it again. Whoops. We want to generate, not run, because we're using a payload, and we can see how the command would have changed. So if you're interested in like debugging it, if you're working on using one of these modules for yourself in some kind of an external POC or anything along those lines, you can go ahead and run this and see how the different options change. But there's nothing too fancy going on right here. The primary advantage is it being integrated into the framework, again, being modular, so that way we have these payloads and they can be directly used in users' exploits without them having to go back and generate it themselves, start up a payload, use the payload, that's the CMD Unix generic one. This is the old one, and you'd have to take that command, you'd have to copy and paste it into this value right here. It's not a very cohesive experience. Now everything has been streamlined. Now, with that, we've talked about how these payloads would go ahead and be used, but let's talk about the differences as they pertain to module developers. Now, if you're interested in writing a exploit, this section should hopefully interest you. Going back to that F5 example, we can go ahead and see this is the source code to that exploit, and we simply have one target in here. Now, if you remember, we used this one target to be able to go ahead and execute a Python interpreter in memory, as well as a interpreter using the new fetch-based payloads over HTTP, and everything just worked out of the box. That's because Metasploit now understands those fetch payloads as true first-class payloads. So as an exploit developer, you could put in your bad characters here, the length restrictions on your commands, and the framework would handle filtering out payloads that weren't going to work for you automatically. Now, in this particular case, there are no bad characters or size restrictions, because once we create the user while we're exploiting this vulnerability, we're simply using an API that's intended to execute OS commands. So the target definition is exceedingly simple. Once that is in place, we simply reference the encoded payload. We base64 encode it to remove bad characters, because I guess we actually are. Yes, we do have bad characters in here because we are posting this into the post request, and we want to be able to wrap it as a single command. So we base64 encode it. But that's it. So I'm not going to go over the rest of the exploit because it's a little off topic for the payloads. But as an exploit developer, you write that one target and you deal with one scenario. You're executing an OS command, which from what we at the Metasploit project have seen over the past few years, we're seeing more and more exploits are ultimately just executing OS commands. Like I mentioned, when this feature came out earlier this year, the prior year, 2/3 of our exploits resulted in OS command execution somehow. That includes like deserialization flaws. A lot of deserialization gadgets will end up executing an OS command. Of course, raw OS command injection vulnerabilities. This particular one would not have been classified as OS command injection. It's AJP smuggling, but once we use that flaw to create a new admin account, again, we're executing an OS command. It's becoming increasingly more and more common for the exploits that we see and that we write and release to be executing OS commands. So that's why we want to be able to optimize for that most common use case. Now, on the flip side of things, if we take a look at the SSH exec module, which this one is quite old, it didn't actually come out in 1999. That's just the disclosure date for the CVE. But we can see this list of targets that scroll on and on and on. And yeah, I actually wrote this one too. I wrote this one quite a few years ago, well before all the adapters were released. But we can see we have an individual target specified right here to execute a Linux command. We have another target for x86 32-bit and 64-bit Linux payloads, and the list just goes on and on. We have all of these different targets that are all filtered out right here. We have a dedicated target just for Python. But the target definitions, these are all pretty simple. So like they are written this way, but the problem, or not necessarily the problem, but the onus is then on the exploit developer to then have to handle each one of these individual targets. So we can see right here, we have this logic right here, which effectively baked in the adapter code into the module. This is straight up not necessary anymore. The exploit author doesn't have to handle this. It's handled by the framework for us to make this a much more seamless experience. You say that you, as an exploit author, you say that you are executing an OS command. This is handled for you. You don't need to worry about dealing with the command stager. So all of this logic right here would all just be really simplified down to just executing an OS command. You have to deal with fewer libraries. You don't have to deal with all the wrapping. It's streamlined and straightforward for you. The framework handles it so long as you say that it's an OS command, and you define again the bad characters and the length restrictions for you. So that really makes things a lot easier from an exploit development perspective. So the fetch-based payloads were the number one thing that I wanted to talk about that the Metasploit project has done in terms of improving the payloads over the past year. But we've also made a number of additional quality of life improvements that I wanted to talk about. The first of which is pretty exciting. It was the first major change in over a decade to Meterpreter's built-in hash dump command. And what those changes bring us is WoW64 support. Now, originally, when the Meterpreter session was on a Windows host, the Meterpreter session architecture, which was from the payload architecture that was selected in the exploit, would need to match the host operating system. And that's because the code stub that was injected into LSASS to perform the actual dumping originated from Meterpreter. So now with these improvements, the 32-bit Meterpreter actually contains both the necessary 32-bit and 64-bit stubs and can determine at runtime which one it needs to go ahead and use. What this means is that if you open a 32-bit session on a 64-bit host, you can now run hash dump, whereas previously you had to open a new session after figuring out what the problem was, and it was not a very user-friendly experience. So we're really happy that hash dump will simply work now as long as you have the necessary permissions. There are going to be no more architecture errors. The next improvement I want to talk about is a brand new update token API that allows a user to be able to go ahead and take a token that they've obtained through some means, whether that be a Windows API that they called through like a post module, as will be in our example later, or through perhaps an exploit, something. Now, once the token is set in Meterpreter, Meterpreter will operate with the permissions that that token has. That's very helpful for the user, the Meterpreter operator, if they want to be able to go ahead and do like file system operations or be able to access things like network shares. We'll see in our example. Finally, there were a few networking improvements to the ability for us to see the configuration of the target host that Meterpreter is running on. The Windows Meterpreter now has the ability to dump the IPv6 routes, which can be very helpful if there's some kind of like a VPN client or something like that on the target, be able to see any static routes that have been created or are in use by any kind of tunnels or anything that are established. And in addition to that, the Linux Meterpreter also has the ARP table inspection, so you can go ahead and see the hardware addresses of hosts that are on the network. Again, we think that that's really going to help users be able to identify additional targets. Now, with that, I want to go ahead and check out a demonstration. Now, to get started with our demonstration for all of these, of course, we're going to have to open a Meterpreter session. So we're going to go ahead and use the ps-exec module that will open a session running as NT-authority system. We certainly don't have to use the ps-exec module. We could pretty much use any module that would deliver us a privileged session, but we're just going to go ahead and use this one as an example. So I'm going ahead and setting all of the different options before we go ahead and run the module, and then finally we will have our Meterpreter session. So the first thing we're going to do is go ahead and see that we're running as NT Authority system. We can see that we're running as a Windows 11 virtual machine, but more importantly, it's a 64-bit system and we're running a 32-bit interpreter. Now, previously, we would have to open a new 64-bit interpreter session by going back into the psexec modules, changing the payload out, and rerunning it in order to use the hashdump command. But now the hashdump command is able to identify that it's a 32-bit interpreter on a 64-bit host. It's running in that WAL64 context, and it's able to function correctly. So we are able to get those hashes. Now the next thing I want to show is the IPv6 routing table. So if we just go ahead and run routes, we can see that below the IPv4, we now have the IPv6 network routes. The IPv4 ones are up above and they're cut off, but the new ones are the IPv6 routes, that we'd be able to see anything that had been statically added via some kind of like a tunnel or anything along those lines that have been established. And finally, we want to go ahead and see if we can access this share on a domain controller. Now, at first we get access denied because we're running as NT Authority system, so it didn't work. But we're going to go ahead and use the new make token module, which is going to issue an API call with the credentials that we are providing, and it's going to set the interpreter token to this new value that we have. And because that is a domain user, we can go ahead and see that now we can access that network share and see the contents of it. So we were able to go ahead and make that token and then set interpreter to run as that token. So now we have those privileges. Now, once we had completed our task, we would go ahead and use the revert to self command, which is going to drop our token and restore it back to what it was originally, in our case, NT Authority system. So we can see once again that we no longer have access to that network share, but we could go ahead and run the make token module again if we wanted to, if we wanted to change to another user or set the token to something different. And with that, I want to go ahead and say thank you very much to everyone for sticking with me through this demonstration to hear about the latest and greatest changes that the Metasploit Framework has been making for our payloads specifically. Everything that I have shown has been shipped over the past few months. It is all publicly available. You can access it on Metasploit.com, or the source code to everything is available on GitHub under the Rapid7/Metasploit-Framework repo. We also have quite a bit of documentation available on docs.metasploit.com that we hope will help folks out. And if you're interested in more information about the fetch payloads specifically, we have a dedicated blog that we released about the same time that we wrapped the project that goes into things in a little bit more depth. And with that, I want to go ahead and say thank you very much. My name was Spencer McIntyre, and if you have any questions, please feel free to reach out.